Hello friends, today we are going to look into the topic real numbers and their decimal expansion. So in this video we will be looking into in detail about real numbers and their decimal expansion, and then we will be solving exercise 1.3 of NCERT grade 9 first chapter. The real number, both rational numbers and irrational numbers, can be represented in the form of decimal form. That is, for example, a rational number, that is 10 by 3, 7 by 8, a irrational number √2 can be represented in decimal form. There are three different cases for rational numbers conversion to decimal form. For rational numbers, case 1, the remainder becomes 0. That is, for example, 7 divided by 8. Case 2, the remainder never becomes 0 with repetition. For example, 10 by 3. For irrational number, that is case 3, the remainder never becomes 0 with no repetition. Example, √2, √3, √5, and which goes on. So now we are going to in detail about the case 1, case 2 and case 3 of converting a rational number into a decimal expansion. So coming to case 1, rational numbers remainder becomes 0. The decimal expansion ends or terminates after a finite number of steps. We call it terminating decimals. For example, that is 1 by 2, the decimal expansion of it is 0.5. The decimal expansion of 7 by 8 is 0.875. Case 2, where the rational number never becomes 0, that means the rational number where the remainder never becomes 0 with repetition. For example, 10 by 3. The decimal expansion of 10 by 3 is 3.3333 and which never stops and it goes on. And 1 by 7, the decimal expansion is 0.142857, 142857, 142857, and this set of numbers keeps on repeating. That is, we call it non-terminating recurring decimals. We can also convert non-terminating recurring decimals to rational number form. That is, for example, 0.3 bar, which can also be written as 0.333, which goes on, can be converted to the form P by Q, which is rational number form. And this we can find in the exercise session that we'll be doing in 1.3. So coming to case 3, irrational number where remainder never becomes 0 with no repetition. Example, √2, √3, √5, √7 and many more. We have seen that in all the above three cases, it's clear that the decimal expansion of a rational number is either terminating or non-terminating repeating. Thus, we can also say that if a decimal expansion is either terminating or non-terminating but repeating, then that number is a rational number. The decimal expansions which are non-terminating, non-repeating, then these are known as irrational numbers. So now we are going to discuss exercise 1.3. The first question of this exercise is, write the following in decimal form and say what kind of decimal expansion each has. So there are 6 subdivisions for this. First one is 36 by 100, second one 1 by 11, third one 4 1 by 8, fourth one 3 by 13, fifth one 2 by 11, sixth one 329 by 400. So looking into the question, first let us see what does this question mean. That is, first we have to find out what are the decimal expansions of these questions and then say what kind of decimal expansion they are. So looking into the question, we can see that each of these 6 questions, 6 subdivisions of the first question are all written in the form of P by Q, and where Q is not equal to 0. That means all of these numbers are rational numbers. And we also know that there are 2 types of decimal expansions that are terminating or non-terminating. So now we are going to solve each one of them and find the decimal expansion and then say what kind of decimal expansion they are. The first question is 36 by 100. Doing the long division method, we can know that the decimal expansion of 36 by 100 is 0.36. And when we get an answer of 0.36, the remainder comes to 0. That is, the division process ends over there and the answer we get is 0.36, and hence the decimal expansion of 36 by 100 is 0.36. And we see that after the decimal, after 2 digits, there are no numbers continuing or neither it is repeating. So we can say that 0.36 is terminating and non-repeating. Thus, the decimal expansion of 36 by 100 is 0.36, and the kind of decimal expansion it is known as terminating decimal expansion. So, the second subdivision of the first question is dividing 1 by 11, that is 1 by 11. We are to find the decimal expansion for this and then say what type of decimal expansion it is. So, doing the long division process, we see that when dividing 1 by 11, we get an answer of 0.090909, and this keeps on repeating. So, the decimal expansion of 1 by 11 is 0.090909, which can also be written as 0.09 bar. We see that the numbers after the decimal point, that is 09, keeps on repeating, that is 0.090909, and it is never ending. It keeps on repeating, that is the remainder never comes to 0. So we say that the decimal expansion of 1 by 11 is 0.09 bar, and the decimal expansion of 1 by 11 is non-terminating, non-repeating. Thus, the decimal expansion of 1 by 11 is non-terminating, repeating. So, the third subdivision of the first question is 4 1 by 8. We see that this question is written in the form of mixed fraction, that is 4 1 by 8, and this can also be written as 33 by 8. On dividing 33 by 8, we see that by doing the long division, we see that the decimal expansion of 4 1 by 8, that is 33 by 8, is 4.125, and the kind of decimal expansion is shown here is terminating, that is 4.125 comes to an end after the remainder comes to 0, that is the decimal expansion is 4.125, and the kind of decimal expansion shown here is terminating. Now the fourth question is 3 by 13. The decimal expansion of 3 by 13 when we do the long division method is that 0.230769. We see that even after the decimal, these numbers keeps on repeating after 9, that is 230769 is repeating again and again, and this never comes to form a remainder of 0. That is, the decimal expansion of 3 by 13 can be written as 0.230769 the whole bar. That is, these numbers after the decimal keeps on repeating and these never comes to an end. Thus, this number, the decimal expansion of 3 by 13 is non-terminating, non-repeating. Thus, the decimal expansion of 3 by 13 is non-terminating, repeating. Now, the fifth question is 2 by 11. The decimal expansion, when we do the long division method, we see that the decimal expansion of 2 by 11 is 0.181818, and this keeps on repeating with a remainder which is not equals to 0. That is, the decimal expansion of 2 by 11 is 0.18 the whole bar, and therefore the kind of decimal expansion of 2 by 11 is non-terminating, repeating. Now the sixth question is 329 by 400. When we do the long division method, we see that the decimal expansion of 329 by 400 is 0.8225, and we see that the remainder comes to 0. Thus, the kind of decimal expansion shown here is terminating. So question number 2. You know that 1 by 7 is equals to 0.142857 the whole bar. Can you predict what the decimal expansion of 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7 are without actually doing the long division? If so, how? So the solution for this is that we are given that 1 by 7 is equals to 0.142857 the whole bar. So now we are going to find for 2 by 7, 3 by 7, 4 by 7, 5 by 7, 6 by 7. So we know that 1 by 7 is equals to 0.142857 the whole bar. So now what we are going to do is that wherever 1 by 7 repeats, we are going to replace 1 by 7 with 0.142857 the whole bar. Okay, so the next one is 2 by 7. We are going to find the decimal expansion of 2 by 7 without doing the actual long division method. So we know that 2 by 7 can be written as 2 into 1 by 7, where we know that 1 by 7 is 0.142857 the whole bar. So we can write 2 into 0.142857 the whole bar. So the answer for 2 by 7, that is the decimal expansion for 2 by 7, becomes 0.285714 the whole bar. So this process keeps on repeating. So the same goes with 3 by 7. We know that 3 by 7 can be written as 3 into 1 by 7. Substituting the value for 1 by 7, we write it as 3 into 0.142857 the whole bar, and the answer for this is 0.571428 the whole bar. Now to find the decimal expansion of 4 by 7, we know that 4 by 7 can be written as 4 into 1 by 7, that is 4 into 0.142857 the whole bar. That is, when multiplying 4 into 0.142857 the whole bar, the answer we get is 0.571428 the whole bar. So the same process goes with the rest too. That is, 5 by 7 can be written as 5 into 1 by 7. Now substituting the value for 1 by 7 in place of 5 into 1 by 7, that is 5 into 0.142857 the whole bar. The answer we get is 0.714285 the whole bar. Now for 6 by 7, we can write it as 6 into 1 by 7. The same as we did above, we can substitute the value for 1 by 7. Then we get 6 into 0.142857 the whole bar, and the result obtained is 0.857142 the whole bar. Thus, without doing the actual long division method, we can predict the decimal expansion of the given rational numbers. So coming to the third question. The question says, express the following in the form of P by Q, where P and Q are integers and Q not equals to 0. So there are three subdivisions for this question. The first one is 0.6 bar. Second question, 0.4 bar over 7. Third one, 0.001 the whole bar. So we see that all these three subdivision questions are given in the form of decimal expansion, and this question has asked us to solve it in the form of P by Q, where P and Q are integers and Q not equals to 0. So coming to the first question, we have to solve this. That is, 0.6 bar can be written as 0.6666 and goes on, and let us name it as equation 1. As there is only one number repeating after this decimal, that is 0.6, and this after decimal 6 keeps on repeating, that is there is a single digit 6, and this number keeps on repeating. Since there is only one number repeating, we can multiply equation 1 with 10 on both sides. That is, the equation 1 now changes into 10x is equals to 6.6666. Let us name it as equation 2. Now subtracting equation 1 from equation 2, we get 10x minus x is equals to 6.666 minus 0.6666. That is, when we solve that third equation, we see that 9x is equals to 6, where x is equals to 6 by 9, which can be further written as 2 by 3. So the fractional form of that means the p by q form of 0.6 bar is 2 by 3. So the second question, we have to find the p by q form of 0.4 bar over 7. So this question is little bit different from the first one. See, let us compare the first question and the second question. In the second question, it is 0.4 bar over 7, that is the bar is only over 7. But in the first question, it was 0.6 bar. There was only one number after decimal and it was a bar over that. But in this question, there are 2 digits after the decimal point and the bar is only over the second number. So the bar is not applicable for the first number, that is 4. So this question is different. So what we are going to do is, firstly we are going to shift the 4 before decimal. It is after decimal. The question is 0.4 bar over 7. So we are going to shift this 4 before the decimal. Let us consider x is equals to 0.4 bar over 7. So to remove 4 from the after of a decimal to before of decimal, we are going to multiply 10 on either sides. That is x into 10, that is 10x is equals to 4.7 bar. And now we are going to continue as we continued in the first question. That is, now since there are only one number repeating after the decimal point, again we are going to multiply 10 on the both sides. So the equation 1, that is, let us name 10x is equals to 4.7 bar as equation 1. Now we are going to multiply 10 on the both sides of equation 1, since there is only one digit repeating after the decimal number. So now it becomes 100x is equals to 47.7 bar. Let us name it as equation number 2. Now we are going to subtract equation 2 and equation 1. When we minus equation 2 and equation 1, we get 100x minus 10x, which is equals to 47.7 bar minus 4.7 bar. Solving this, we get 90x is equals to 43. That is, x is equals to 43 by 90. So the p by q form of 0.4 bar over 7 is 43 by 90. So coming to the third question, that is 0.001 the whole bar. We are going to find the p by q form of the decimal expansion of 0.001 the whole bar. We can say that x is equals to 0.001001 and this keeps on repeating, and let's name it as equation number 1. We can see in this question that there are 3 digits repeating after the decimal. So we are going to multiply 1000 on the either sides of this equation 1. That is, the equation 2 now becomes 1000x is equals to 1.001 the whole bar, and let us name it as equation 2. Now subtracting equation 1 from equation 2, we get 1000x minus x is equals to 1.001 the whole bar minus 0.001 the whole bar. And the solution for this is 999x is equals to 1, that is x is equals to 1 by 999. That is the decimal expansion 0.001 the whole bar gives a form that is 1 by 999 in the form of p by q. Now question 4. Express 0.9 bar in the form of p by q. Are you surprised by the answer? Discuss with the teacher and classmates and say why this answer makes sense. So now we are coming to the solution part. We see that, let us take x is equals to 0.9 bar and let us name it as equation 1. As there is only one number repeating after the decimal point, we can multiply 10 on the both sides of equation 1. That is, equation 1 now becomes 10x is equals to 9.9 bar. And now let us name it as equation number 2. Subtracting equation 1 from equation 2, we get 10x minus x is equals to 9.9 bar minus 0.9 bar. When we minus equation 1 from equation 2, now the solution we get here is 9x is equals to 9, that is x is equals to 9 by 9, which is equals to 1. That is, the p by q form for 0.9 bar is 1. As 0.999 goes on forever, there is no such big difference between 1 and 0.99999. That means we say that is the surprise over here is that we started with 0.9 bar and we reached at the conclusion that the p by q form of 0.9 bar is 1. Since there is no much difference between 1 and 0.9 bar, we say that this is a surprise and that both of them are equal. Question 5. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. So solution is, in 1 by 17, the divisor is 17. That is, since the number of entries in the repeating block of the digits is less than the divisor, so as I said before, if the divisor is 17, the maximum number of repeating block would be 1 less than the divisor. That means there will be 16. So we are going to confirm this by doing the long division method of 1 by 17. When we do the long division method of 1 by 17, we get an answer of 0.0588235294117647 the whole bar. So here the remainder never comes to 0 and the numbers and this numbers, that is this 16 numbers, is again repeating. That is, remainder is the same digit from where we started the division. Thus there are 60 digits in the repeating block and of the decimal expansion of 1 by 17. Hence our answer is verified. So coming to question number 6. Look at the several examples of rational numbers in the form of p by q and q not equals to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representation. Can you guess what properties q must satisfy? For the solution, let us look into the decimal expansion of the following terminating rational numbers. We observe that the prime factorization of q, that is denominators, has only powers of 2 or powers of 5 or powers of both. For example, let us consider the rational numbers 1 by 2, 7 by 8 and 4 by 5. So now we can see that the decimal expansion of 1 by 2 is 0.5 and the q, that is the denominator, can be written in the form of 2 to the power 1. Likewise, the decimal expansion of 7 by 8 is 0.875 and the denominator q can be written in the form of 2 to the power 3. And for the next example, that is 4 by 5, the decimal expansion is 0.8 and this number, that is the q of the denominator of 4 by 5, can be written in the form of 5 to the power 1. We can observe that the terminating decimals can be formed in the situations where the prime factorization of the denominator is either of 2 or of 5 or of both. Coming to question number 7. Write 3 numbers whose decimal expansions are non-terminating, non-recurring. That is, for solution, let us look into the question once more. It has asked us for 3 examples which should be non-terminating, non-recurring. That means they have asked us for 3 irrational numbers. So the answer for this is root 2, root 3, root 5. Root 2 can be written as 1.414213562 and it goes on. Root 3 can be written as 1.7320508808 and it goes on, and root 5 can be written as 2.23606797 and it goes on. So moving to the next question, that is question number 8. Find 3 irrational numbers between the rational numbers 5 by 7 and 9 by 11. To find the solution for this, we have to divide 5 by 7 and 9 by 11 using the long division method. So when we divide 5 by 7, we get an answer of 0.714285 the whole bar, and when we divide 9 by 11, we get a solution of 0.81 bar. So we are asked to find 3 different irrational numbers between 5 by 7 and 9 by 11. So looking into the decimal expansions of these 2 numbers, we can find that the result we get is non-terminating and repeating. So 3 rational numbers between 0.714285 the whole bar and 0.81 the whole bar are 0.750, 7500, 75000, and it goes on. The second one is 0.7670, 76700, 76700, and it goes on. And the third one is 0.780, 800, 7800, 8000, and it goes on. So looking into these three examples, you can clearly find that none of these numbers are terminating or non-repeating. It is non-terminating and non-repeating. So now let us look into question number 9, that is the last question of exercise 1.3. Classify the following numbers as rational or irrational. There are 5 subdivisions for this. The questions goes like, first one square root of 23, second one square root of 225, third one 0.3796, fourth one 7.478478 dot dot dot, fifth one 1.10, 100, 1000, 100001 dot dot dot. So the first subdivision, that is root 23. 23 is not a perfect square. Therefore, square root of 23 is an irrational number. Coming to the next one, that is square root of 225. The square root of 225 is 15 into 15, which can also be written as 15 square. That is, 225 is a perfect square, and hence square root of 225 is a rational number. So moving to the third subdivision, that is 0.3796. So looking into the question, it is crystal clear that this number is a terminating number, that it comes to an end after the digit 6. That is, 0.3796 is a terminating number, and hence it is a rational number. So coming to the fourth question, that is 7.478 bar. That is, we see that 7.478, the whole bar, the bar is applied for all 478, which is coming after the decimal number. Since 7.478, the whole bar, is a non-terminating but a repeating decimal, we can say that the given number 7.478478, that which goes on, is a rational number. So coming to the last question, that is to find whether 1.10, 100, 10000, 1000001, which goes on, is a rational or an irrational number. We see that the given number is non-terminating and non-repeating. That means, which is very clear, that the given number is an irrational number. So students, we have come to the end of exercise 1.3, and in all the examples or exercises of this 1.3, we have seen the real numbers and the decimal expansion. Hope this 1.3 exercise 1.3 is clear to you. So study well, and in the next session we will be solving exercise 1.4.